All right, class, welcome to section 3.1 on terminology. So what I want to do is just take this time to go through just some definitions concerning this section that will look at the basic definition of probability and define some of the definitions that go along with that in terms of counting, and then also how to apply probabilities in this section. This section is important. This will lead into other sections too. This is the only section we're going to cover in chapter 3. So I want to spend this time, in fact, probably my videos are going to probably be a little bit longer on each problem because I'm only doing a few problems concerning this section 3.1 as it leads into chapter 4. So let's go ahead and start here with this topic here with experiment. So an experiment is something that you do by chance in that way that has a probability attached to it. Here it says an operation carried under controlled conditions. So just think of a more simpler way that, and as we look at these, a probability is attached to it. And in some ways, as you know, we think of what's the chance to get struck by lightning, what's the chance it's going to rain tomorrow, things like that. Different tools are used to, calculate how that's done. So that's what we mean by, in that way, an experiment. Because normally, how could you tell, like, you would get struck by lightning tomorrow? It's probably not even possible. And hopefully no one ever gets struck by lightning or anything like that. So in that part, it's true that when it talks about for under control conditions. The last part of this is called chance, and so that's kind of what I was referring to, where the chance is going to rain tomorrow. We're looking at stage experiments here to try to maybe get close as possible, but we can't really predict what's going to happen tomorrow anyway. So the best thing that we can do at this point is look at what's called an, sorry about the printer, an outcome, and defining each one of the different components. This first one is called a sample space. The sample space is the set of all outcomes. Again, the set of all possible outcomes. And each one of those elements inside the sample space is called an outcome. So think of it as, so here we have, and the sample space is a set of all outcomes. Think of an outcome as like a combination. What would be the combination on your lock? Say 1, 2, 3, 4. And it could be one number, a sequence of numbers. It doesn't even have to be numbers. It could be an entity, like, even the numbers on a quick pick on a lottery ticket would be considered outcomes. So if you went over here to 7-Eleven or Fast Strip and said, hey, I want to get, 5 quick picks, those would be 5 different outcomes when trying to figure out the lottery. Once we have that, we're going to create this thing called a tree diagram or a Venn diagram. And those will be ways that we can use to organize and figure out. So I'll put a remark here. Ways to find the sample space. So underneath this, we have what's called an event. An event is a subset of the sample space. Okay. And we're going to use that concept to try to find probabilities. So the basic definition that I have down here. So there's basically three types, or actually here we're going to look at two types of probabilities, but this is one of them here. So we're going to follow for now what's called a theoretical probability. There's another two called empirical probability, and then there's another one by your experience, your background in something would be another way to find another probability. Here in this thing, the definition says the number of outcomes in event A over the number of outcomes in S. And what they mean by S is a subset, or sorry, the sample space. And then A is just some event. So we don't know what the A is. We know A is a subset of the sample space, but A is based upon a condition. And here we write it as, event A, and I'll put another tag here that it's based upon a condition. So I want you to see here, even with the notation, that with the probability of A, P of A, so this is function notation like f of x, where you place the event into the function and the output is this, and we have to figure out the guidelines of the numerator and the denominator here. So again, the numerator is a count of the values in, or the number of outcomes in the event A. And against A is based upon a condition, what somebody made up. Once we figure out counting, then we also have to know here for the denominator, what's the count of all the outcomes in the sample space. Dividing those two numbers, or representing those two numbers as a fraction or a ratio, is our probability. And some of the things down here to consider as well, that all probabilities are between 0 and 1, and that another way to look at that is between 0% and 100%. That you could never have a probability that is negative or above 1, or in this case as well, less than 0% or more than 100%. Those are our bounds for measuring probabilities. So we'll consider that when we look forward here, and especially into chapter 4. And then another point here is that the sum says the sum of all probabilities must be equal to 1. We'll pick up that topic more when we get to chapter 4. Also, we look in here what's called a complement event. Events are complement of one another if you have the sum of two events is equal to 1. And this is the definition of complements. So you have this probability of A, and then plus another probability, we call it A prime here, and A prime is defined as the complement of A. This is really easy to do using the word not. So in other words, it is the case I went to the store. It is not the case I went to the store. So again, with the word not, we quickly have the complement of the event of, and then we can find the complement probability. So there's kind of two things to be careful of that I want you to aware, and this is most often, this is not common, like A prime, is not the same as the probability of A prime. And the same thing goes, event A is not the same as the probability of event A. And in the language, people often get those mixed up, even though I kind of know what they mean. So be careful when we're talking about events A prime or A versus the probability of those events. They're different outcomes. And so here what I'm saying is that the sum of those probabilities is equal to 1. If that happens, then you know that you have a complement. And that's the thing here to be aware of. And that can only happen with 2, not any more than that. If we have more than one event in that way, we can kind of trick it to make that happen, but that's just, we have to make it very basic, like black and white in that way. So along with this formula up here is we get this thing down here, that we know to find complement probabilities by subtracting the regular probability from 1. It's pretty easy to do, and we'll do that later. And the last thing down here at the bottom is dealing with conditional probability, and it's this thing here, that no matter how it's written, probability of A given B, or the probability of B given A. So I'm saying that our vertical line here is like the word given. It really doesn't mean that. It kind of more means that we're given this B, given B, or more or less, let me leave that in quotes there, given that B has occurred. But that can have several different meanings, of course. It just depends upon what the occurrence of B implies. In other words, as well, it would be kind of considered as a starting point. So in other words, maybe here it could look at as start off with the letter B. Start off with B. And that's misunderstood because you could see here that B is the second letter as we're kind of looking at this, that, you know, you pronounce this from left to right. You look at A and then you look at B. And I know that B is the second letter of the alphabet, but still it doesn't really matter because in this notation here, we're considering the second one. This B is the one that comes first. And then you look at A. So read this backwards in a way. Look at the B and then you jump back over to the A. And the same thing comes over here. You look in this notation. This is the probability of B given that A has occurred. So here in this right, we assume that A happens first, and then you jump back to see what the probability of B is. So that is the just an introduction to the definitions that we're going to look at as I go through the different examples here in 3.1.